All right, let's jump right in. In the world of electrical wiring, there's this technique that's kind of like a double-edged sword. It's both a really clever shortcut and a potential hazard. Today, we're going to demystify the multi-wire branch circuit, or as you'll often hear it called, an MWBC. So, what's the deal with these things? Are they a brilliant way for electricians to save a bunch of wire and labor, or are they a hidden danger just lurking inside your walls? Well, the truth is, it's kind of both. See, an MWBC can be an absolutely fantastic tool. But, and this is a big but, only if you follow the rules to the letter. If you get it wrong, the risks are, well, they're very real. Let's break down exactly what that means. So, first up, let's talk about why these circuits even exist in the first place. I mean, it all comes down to being a really smart, really efficient way to run electrical wiring. Okay, so what is an MWBC, really? The magic is right there in the definition. It's a circuit where you have two or more hot conductors, but they all share one single common neutral conductor. Think of it like this. Imagine a highway where instead of every car getting its own lane to return home, a bunch of them share one big carpool lane on the way back. That's basically what's happening here. It's a really elegant way to save a ton of copper wire and, space in the conduit. But this whole carpool system only works if everybody follows the rules of the road, and the first one is absolutely non-negotiable. All the wires in the circuit, every single hot wire and that shared neutral, they have to start from the exact same electrical panel. You can't mix and match. It's a foundational rule for a reason, as we're about to see. And that brings us right to the first huge safety requirement. It's all about making sure you can turn the entire circuit off all at once. This is where things get really dangerous. Picture this. You're going to work on an outlet. You go to the panel, you find the breaker, and you flip it off. But with a badly wired MWBC, you might have only shut off one of the hot wires. That shared neutral you're about to touch, it could still be totally live, carrying current from the other circuit that's still on. It's an invisible and, honestly, a potentially lethal shock hazard. So, to prevent that exact scenario, the electrical code is crystal clear. It demands a way to disconnect all the hot wires, what the code calls ungrounded conductors, at the exact same time. The key word here is simultaneously. One flip of a switch has to kill all the power to the entire circuit, no exceptions. So what does that look like in the real world? Well, on the left, you see what you absolutely should not do, just putting two separate breakers next to each other. That's a huge no-no, super dangerous. The right way is to use either a double pole breaker, that's the one solid unit, or two single pole breakers that are physically locked together with what's called a handle tie. This way, if you flip one, the other one has to go with it. Guarantees they both turn off. Boom, problem solved. Okay, so we've tackled the shock hazard. Awesome. But there's another major risk we need to talk about, and this one has everything to do with connecting the loads, the outlets and devices, the right way. The other major danger here is fire. See, the genius of an MWBC is that the currents from the different hot wires are supposed to basically cancel each other out on that shared neutral. But if you make a simple wiring mistake, you can actually reverse this, causing the currents to add up instead. This can dangerously overload that neutral wire, essentially turning it into a heating element inside your wall, and that is a massive fire risk. So the code's solution is to put some restrictions on how you can connect your devices. The main rule is this: MWCs should only power line-to-neutral loads. Now, what does that mean? Essentially, we're talking about your standard 120-volt devices, like a lamp you plug into a regular outlet. This is what ensures the physics of that current cancellation works like it's supposed to and keeps that neutral wire safe. But like with many rules in the code, there are a couple of specific exceptions where you can bend this one. So the first exception is when you've got a dedicated appliance. If the entire MWBC is just running to a single piece of equipment, think of a big appliance like an electric stove or a dryer that needs both 120 and 240 volts, then in that specific case, it's totally okay to supply those higher voltage or line-to-line loads. The second exception, well, it brings us right back to that special breaker we were talking about. If you're using a breaker that trips all the hot wires at the same time, like those double pole or handle-tied ones we looked at, then the circuit is also permitted to supply line-to-line loads. That extra safety feature built into the breaker provides the protection you need. All right, one last major rule to cover. This one is less about physics and more about just good, solid craftsmanship and safety for anyone who might have to work on the system down the road. This final rule is actually pretty simple, but it is so crucial for future safety. All the wires of a single MWBC, that's the hots and their shared neutral, they have to be physically grouped together. You usually do this with a cable tie or just by keeping them all inside the same cable sheathing. It's a simple visual cue that basically tells the next electrician, hey, these wires are a team. Treat them as a single circuit.
So, we've covered the key hazards and the rules to keep things safe. Let's boil it all down into a simple 3-point safety checklist. Number 1, and this is the big one that protects you from getting shocked. Always use a common disconnect. That means a double pole breaker or a handle tie, every single time.
Number 2, to prevent a fire, you've got to stick to line to neutral loads. Remember, unless one of those two very specific exceptions applies, this is the rule that keeps your neutral wire from turning into a toaster element. And finally, number 3, for the sake of the next person who has to open that electrical box, group your conductors. Keep all the wires of the circuit physically bundled together to avoid any deadly confusion later on. So here's the bottom line. A multi-wire brand circuit is a smart, efficient wiring method that can save you time and money. For sure, but it is absolutely unforgiving if you make a mistake. Following these code rules isn't just, a good suggestion, it is essential for a safe and reliable installation. So there you have it. The MWMBC is a seriously powerful tool, but man, it's one that really demands respect and precision. But you know what? The story doesn't totally end here. The code itself drops a hint about a whole new challenge, something called harmonic currents that come from all our modern electronics. These can add a whole other layer of stress to that shared neutral wire. So the question becomes, how do we deal with that? Well, that's a great topic for another time. Thanks for digging into this with me.